All right, here we go. So this time I'm going to make a graph. Shh. So I'm going to make a little histogram, and I'm going to label I wish I had some straight lines here. I think I'll label the left side of this graph. I'm going to label it in 16ths. So that's 1, 2, 3, 4, 5, 6 16ths. And then my horizontal axis, I'll go 0, 1, 2, 3, 4. And for 0, it was 1 16th, 4 16ths, 2, 3, 4 16ths. For 1, 6 16ths for the 2, 4 16ths for the 3, 1 16th for the 4. Describe that histogram for me, even though it looks kind of ugly. Yes. Yes, you're gonna make little. Yeah, you're gonna make little histograms. Okay. Yeah. This one's symmetrical. Yes. I see. Yeah. Okay. So let me form some questions. Come on. Down a little further. Down to this mess down here. Whoops. Eraser. Give me the eraser. Okay. All right. So I want to figure out from either the histogram or the probability distribution or from the organized list we made. What's the probability I get exactly 3 heads? And the way I'm going to write that is the probability that my random variable is 3. And how many were 3 heads? 4. So the probability of 3 heads is 4 out of 16. Or 1/4. Right, yeah. So I'm going to formally write out these probability statements because they're going to come in handy a little later. Okay. So I'm going to ask, what's the probability that I get at least 3 heads? Okay. So at least 3 heads would be 3 heads or 4 heads. And that would be my maximum. So I got to have x greater than or equal to 3. Which would be the probability that x is equal to 3. Or the probability that x is equal to 4. Which is 4 16ths and 1 16th, which is 5 16ths. Okay? So that's how we'll use this. Okay? So kind of simplistic here. Let's go on to a different example. This one comes from the Developmental Psychology Journal, 1986, and they did a probability distribution for the age when these male college students began to shave regularly. So let's look at the example that they're going to give us here. And what do you think the youngest age is here? 13, 14. So last period they got it. 11. 12, 13, 14, 15, 16, 17. I don't know the answer to that question. So x is my random variable, and in this case, x is going to be the age that these males began to shave. If you have a calculator today, you could get it out because we may need to do some calculations here. All right, so I'll give you the data. 1.3%. started shaving at 11. Then they had essentially 0 at 12. And then they got 2.7 at 13 and 6.7 at 14 and 21.3 at 15 and 26.7 at 16 and 24% at 18 and 9.3 and 6.7 and 20 and above 1.3. Okay, so for this to be a legitimate probability distribution, all the probabilities need to be between 0 and 1, duh, and all these probabilities got to add up to 1. So you may verify that if you want, but that I'm hoping that the sum is 1. I'm not going to verify that part. Okay. But I will make a little histogram. You don't say that. I heard that. You hate histograms? How can you hate histograms? You love ogives but not histograms? Ah, God. Well, you know, how do you think that makes them feel? God. Okay, so let's see, for age 11, 1%, a very low bar. I made a little high. 12, 0, 13, 2.7, so it needs to be a little higher than that other one. 14, 6.7, so about more than halfway up here. 21.3, I can go up to there. 26.7, there we go. 24, 9.3, 6.7, and 1%. There we go. There's the histogram. And this is ages. Start shaving. Started. Come on. Okay. So now I'll ask some questions. What's the probability that one of these students started shaving before they were 14 years old? So I'm going to ask that as probability that X is less than 14. So 0.013 plus 0 plus 0.027 is exactly, okay, 4% of them started shaving before they were 14. What's the probability that they started shaving between 13 and 17, and I'll say inclusive? 7.067, 0.213, 267, and 24, 0.814. Thank you. Where is the center of this distribution? 16. So most, does that ring true? Most males start shaving around 16? Yeah. So some at 11 maybe, and yeah. And then you started shaving in the womb. Nice. One of my brothers started shaving at age 12. He also started balding at age 12. So, it's like,